request Mr. Mohammed Sohel from Hyderabad Institute of Technology and Management. He will be talking about solar water purifier.
A warm good afternoon to one and all. I am Mohammed Sohel from Hyderabad Institute of Technology and Management. First of all, I would like to thank UBA Nectar for organizing this event for this conclave, and also I would like to thank our institute for supporting us. So our project title is Solar Water Purifier. So, next slide. Our teammates, we are a team of 4 members from multidisciplinary departments. Myself, Mohammed Sohel, Shiba Shaista, Saujanya, Ramya, and P. Krishna. Next slide, please. Our working principle. We work on a principle of, first we go with a project identification with a survey, and then we develop the specific development with a problem statement by taking the problem statement from the survey, and we, after the specification development, we go for the conceptual design. After designation, we go for the detailed design, that means the product design, and then we take the next step as a delivery. In between detailed design and delivery, we once again confirm with the delivery partner, the community partner, with the product, with their comments and remarks. Then we go for the service maintenance and then for the delivery. So as our problem statement, our institute Hitam has adopted UBA adopted village Basurgura. This village is an UBA adopted by our institute. It's located in Medchal of Hyderabad. While we went for the survey, we have found that the people of this village are facing with a water problem, clean water problem. So we went for the solution. This project is under the clean water and sanitization. Next slide, please. So for this, the required sources we need for this project solar water purifier are generator, solar panel, ceramic files, UV filter, ionizing resin, safety circuits, battery, and pins. Next slide, please. This is the block diagram of our project, solar water purifier. Here we consist of carbon filter, UF filter, ion exchange, including with the pump, battery, and inlet and outlet. Next slide, please. So this is the conceptual design of our project, which includes a detailed ideation of our project innovation. Next slide, please. So here comes the working. This purifier mainly works on sunlight, with the help of sunlight, because we are using here the solar panels. So here we collect the water from the convert bin. As the sunlight raises the temperature of the water is evaporated and leaves the contaminants behind. The water goes to the condensations under the glass or plastic, cover the drops of water, collect in a pure water channel. Next slide, please. So for this problem, we have proposed a solution. We have used three methods. One is UV filtration, ceramic filtration, and ionic resins. UV filtration is with the help of UV light, the water is filtered. And the ceramic filtration is the type of filtration which removes the fine dust in the water. And ionic resins remove the calcium and magnesium ions from the water of exchange. This is the 3D model of our project. Here is three filters, one boiling area and clean water, one is on outlet, inlet, electric wire, and a solar panel. Next slide, please. So how it's related to the Northeast region? In Northeast region, the backward villages are not able to get pure water. Like people are facing for the problem of pure water. So this project, this innovation can be helpful to them. Next slide, please. So this is the cost and the budget of our project. The generator cost 500, solar panel 2,500, ceramic filter 1,500, UV filter 3,000. The overall cost is nearly like 12,000. Next slide, please. Here the strategies used to provide the access to clean water to make solution over affordable to the maximum filtration will be achieved. To empower the families by clean water source right at their homes instead of spending money on the private water suppliers. Next slide, please. So here these are the existing methods which are already in the market. One is ultrafiltration, that is UV filtration method, electrolysis and reverse osmosis. As we know that these methods are already exist, and the last method, which is reverse osmosis, is the highlighter of this from these three methods. And the drawback of this is it wastes nearly 70% of water from out of 100% and give only 30% of filter water. So mainly we can see the government is already opposed to this RO method. Next slide, please. So the performance of our project will be accessible to everyone, and one-time payment for acquiring this device. The cost of the device will be decided by the committee consisting of the both engineers who built it and the local volunteers. Next slide, please. The scalability of our projects. Like we have done a survey and found this scalability. Per day expenditure for a family is 15 rupees. And the total village expenditure is of total 50 families is 750 rupees. So the total cost for the total village will be around 22,500 of 75 members. Next slide, please. Here is the sustainability. The committee responsible for the project will train the local members on the basics repair, such as like basics repair in the filter as a diagnosis and repairing the compounds of it if necessary. Next slide, please. Ethical standards. Necessity and the impact of project is observed to provide the access of clean water to make the solution more affordable. To the maximum filtration will be achieved. Next slide, please. So here, this is the result. Our project can help the villagers with pure drinking water to empower the families by clean water source right at their home instead of spending money on the private water suppliers. So this is next slide, please. So this is about our innovation, our ideology on solar water purifier, and I'm sure that this will be helpful for the middle class and the low class and the backward villagers to get a pure water at their home. Thank you.
Would there be any questions for Mr. Sohel? Yes, sir. Please.